Hello and welcome to Still Behind the Bench. My name is Adam, and on this channel I will attempt to describe the science behind distilling in a more technical way. Hopefully it'll whet your appetite to learn more, and you'll learn enough so that you're more self-sufficient. So for this video I'm going to talk about osmotic stress. But before we get started, I'm going to start an experiment. This here is a regular large chicken's egg that I have removed the shell from. Here, let me get it out of the... This is just tap water. See? Squishy. I've weighed it. It weighs 93 grams. I'm going to be placing it in this sugar water solution, which has a specific gravity of 1.155. And then at the end of the video, we will check the egg's weight again and see what it is. So let's get started. I will be going over what osmosis is, what osmotic stress is, as well as osmotic potential, osmotic pressure gradients, and all the bits in between. It may seem like a lot, but not really. What is osmosis? It's a form of diffusion that applies to any solvent, but in our case it really only applies to water. It is a process where water will pass through a semi or selectively permeable membrane. In this case it's the cell wall and cell membrane of the yeast cell. Water going in, water coming out, trying to reach a state called isotonicity. I will get into what isotonicity is in a few moments. So, osmotic potential can be thought of as water concentration. Distilled water has a osmotic potential of 0, and as you add more solutes into the water, the osmotic potential value actually becomes more negative. So a high concentration of solutes means a lower concentration of water, leading to a lower osmotic potential, and vice versa. A low concentration of solutes means a higher concentration of water, leading to a higher osmotic potential. Water flows from a high osmotic potential to a low osmotic potential. Counterintuitively, not high pressure to low pressure. Osmotic pressure then is the amount of pressure needed to stop that flow of water. It is also the amount of pressure caused by that flow of water and not pressure causing the flow. The difference in those two amounts of pressure is called the osmotic pressure gradient. So the amount of pressure needed to stop the flow and the amount of pressure generated by the flow. That difference is your osmotic pressure gradient. So back to the yeast cells. Yeast cells create their osmotic potential by two processes. One is called Osmo Tolerance and the other is called osmoadaptation. These are very complex, or I should say very detailed and long processes. So I've included a DOI to a study down in the description. These two features allow the yeast to make the osmotic potential slightly higher or slightly lower inside the cell, and the cell has the ability to control that osmotic potential, but only by so much. This leads us to tonicity. Tonicity is the measurement of osmotic pressure gradient. There are three main types of tonicity. Isotonicity is where the osmotic potential inside the cell is the same as outside the cell, so there's no flow of water. Hypertonicity is where the osmotic potential is higher inside the cell, so there is less solutes inside the cell than outside, and water flows out of the cell. And finally, there's hypotonicity, where the osmotic potential is lower inside the cell than outside the cell, and so water flows into the cell. When you move too far into a hypertonic or hypotonic environment, like if there's too much sugar or mineral salts in your water, making it hypertonic, or if there are no sugars or mineral salts, making it hypotonic, you induce a state on the yeast cell called osmotic stress. This is because the yeast cell needs a certain amount of water in it for it to function properly, just like we do. And when you step outside that range, you're effectively pulling in too much water or pushing too much water out. This can damage the cell by increasing or decreasing what is called turgor pressure. Turgor. Turgor pressure is caused by the water inside the cell membrane, and it pushes that cell membrane up against the cell wall. You should also know that the cell membrane is attached to the cell wall in certain places by a compound called chitin, C-H-I-T-I-N. In the case of a hypertonic environment, too many solutes will cause water to flow out of the cell, causing a drop in turgor pressure. The cell membrane will start to pull away from the cell wall, and if it happens enough, the cell wall will actually collapse with the cell membrane, as you can see in these photos. The one is 20% sorbitol, which is a sugar alcohol, and the other one is only 10% ethanol, which is the ABV that most people aim for when making a spirit wash. So this obviously kills the yeast when we have this kind of collapse. But if it doesn't reach that point, the yeast will fire up its metabolic stress responses, which end up producing all kinds of compounds. A lot of them produce what might be toxic byproducts to the yeast. So it will try and dump those outside the cell, and we end up with congeners in our wash. Some of them good, some of them bad. In the case of a hypotonic environment where there's too little solutes, water will flow into the cell through the cell wall and cell membrane, increasing turgor pressure instead of decreasing it. And if that pressure gets too high, it can cause the cell membrane to push through the cell wall like a hernia. And then the membrane itself can burst, releasing all the innards of the cell out into the environment. Remember that scene from the end of Alien Resurrection with the half-human white xenomorph? And it gets pulled up against the window and all its guts get shot out into space? Obviously, this kills the yeast. I doubt you'll ever actually get anywhere close to hypotonicity though. You would need to put your yeast directly in distilled or deionized water. Just don't do that and you won't have any issues. If you're making a yeast starter, use tap water, or if you want to use distilled or deionized water, then add some mineral salts to it first. We can sort of measure the amount of solutes with specific gravity. Try to keep the specific gravity above 1.000 and keep it below 1.150 before you pitch your yeast. If you go below 1.000 and you risk bursting your yeast. If you go above this level, 1.150, which is roughly the same as 400 grams per liter sugar in water or 3.3 pounds per gallon sugar in water, you run a high risk of collapsing the yeast altogether. And that's, it's not that difficult. Osmotic stress is a pretty simple topic. If your pre-fermentation wash mash water is hypertonic, in this case, above 1.150, just dilute it. And don't pitch your yeast into distilled water. Let's take a look at the weight of that egg now. See what happened to it. All right, so here we are with the egg. Take it out, dry it off. And we will see how much it weighs. So it is down to 82.3 grams. And originally it was 93 grams. It's quite the drop, and it's only been about maybe 10 minutes, 15 minutes, about that. Yeah, that's a pretty significant drop. And that is osmotic stress. So please click like and subscribe if you would like to see more content like this, and have a great week.